Okay, here we go. Now we're going to talk about percents. Percents, you've heard these before. You've probably seen percents all over the place. But did you know that they were ratios? In fact, percents are basically proportions, okay? That's how we figure them out. Now, I told you at the beginning that when we were talking about rates and unit rates, we were looking basically at a part-to-part ratio. Percents are most decidedly part-to-whole ratios. Here's why. Anytime I have a percent, let's say I go to the store and I'm looking for a new polo, since I need more polos, and I get to the rack and ooh, 30% off. Wow, that's awesome, okay? That means whatever the first price was, I get to save 30%. That means I'm gonna pay less than I normally would have. Now what does that 30% mean? Well, just like the word seems to say, percent means for every 100, okay? This word cent, that comes from another, I think, Latin word, that means 100. And per just means for every. So for every 100, there's this number that really counts. That means I can write a ratio out of that. 30% would mean 30 out of 100. This is a ratio, and it's a part-to-whole ratio. I'm going to write this here just to remind us that. Okay? 100 represents the entire thing, the full price of the polo. 30 represents part. That means there is 30 parts out of this 100 that I'm not going to have to worry about because I get 30% off, right? Okay? Now, here's where the proportion part comes in. If I want to know exactly what that means, 30% off, there's a couple of things I'm going to have to know. Well, first of all, I'm going to need to know the original price of the shirt, correct? And that will then tell me how much money I'm actually going to get to save. And again, this is another part-to-whole. I have two part-to-whole ratios that are equivalent and form a proportion so that I can actually find out how much money do I get to save. So, let's say that my shirt, and we're going to try to keep this relatively easy, is 25 bucks. I went in, there was a $25 polo, but I know I get to save 30%, okay? How much money do I get to save? That's what this one is, okay? So all I have to do is find out how to complete this proportion. What is this missing value? And we've had practice with that, right? We've had plenty of practice with that in Unit 1. So what are we going to have to do to the two numbers that we do have so that we can figure out this top part? Since I'm going from this side to find this unknown value, I'm going to start with 100 and ask myself, what do I have to do to get from 100 to 25? Well, I'm going to divide because I'm getting bigger to smaller. What number would I divide 100 by to get to 25? I'm going to divide by 4, right? This times 4 is 100, so that makes sense. Which means I'm going to have to do the same thing up here to the top because I can't change this relationship. And I'm going to divide 30 by 4. Let's do that. 4 does not go into 3, but it does go into 30. And the closest number I can think of that's a multiple of 4 is 27. So, I'm sorry, 28. And that's 7 times 4, right? 30 minus 28 gives me a 2. Now I want to keep going because this is money. So I can put a decimal here and here, and I can just keep going. Let's add a 0 here and bring it down. How many times does 4 go into 20? 5 times. And that's also going to actually finish this for me. But I'm missing the cent. So I can just go ahead and fill that in with a 0. Okay? This quotient tells me how much I'm going to save off of this shirt. Okay, so I get to save 30%, 30 out of 100. And this bottom section, again, represents the whole, right? This is the whole of the percent. This is the whole price of the shirt. Since I'm saving 30%, that basically means that I'm gonna save $7.50. That's good to know. That means I don't have to pay $7.50. I have a final question though. How much is the shirt gonna be? Okay? How am I gonna, if I know what the discount is, what's the final price gonna be? Well, that's simple subtraction. Take the original price, which was $25, and subtract my discount. Okay? 0 minus 0 is 0. I can't take 5 from 0, so I'll go ahead and borrow 1 from here. 10 minus 5 is 5. Decimal comes straight down. This is something that we're going to see a lot of in the next unit. And 24 minus 7 is 17. So originally this shirt was $25, right? Since I get to take $7.50 off, because that's 30%, now I only have to pay $17.50. Lucky me, I walked in right at the right minute, or the right day. Good. Let's try something else. Let's not talk about money right now. Let's talk about my friends. Okay? Let's say I get onto Facebook and there are 50 of my friends there. Okay? This is not a percent, by the way. This is an actual count. So I'm not going to put it on the percent side. I have a total of 50 friends. Is that going to go here or here? Top or bottom? It represents all of my friends, so it's going to go right here where it's whole. So I have 50 friends. Okay? I notice that 35 of them wear glasses in their profile pictures. So out of my 50 friends, I have 35 of them that actually have glasses on. Okay? Here's my question. What percent of my friends wear glasses? Okay? Am I going to be trying to figure out the part or the whole? Well, which number does represent the whole, all of my friends? Which percent number represents everybody? Did you say 100? Because that's correct. If I'm talking about all of my friends, that's 100%, right? It's 50 people, but 50 people is everybody on my friends list. So that's 100%. Okay, good. All I need to know now is what percent of that 100, what part of that 100 actually wear glasses in their profile picture. So I don't know this yet, but I know I can find it pretty easily because it's a proportion. So all I need to do is solve this proportion. Now I know I could easily use a factor here, but just for the heck of it, let's practice the cross multiplication, okay? Let's go ahead and cross multiply the two numbers that we can cross multiply. That's 35 and 100. Okay? Now this looks like it's probably, I mean, you could probably do this in your head and you're like, duh, 3,500. But let's go ahead and run through the algorithm because again, we're gonna be doing a lot of that next unit. 0 times 5 is 0, 0 times 5 is 0, and 1 times 5 is 5. Now I'm moving into the tens place, so I'm gonna go ahead and start a new row. 3 times 0, 3 times 0, 3 times 1. And this is just straight up and down addition. Okay, so there's 3,500. Now that was cross multiplying the two numbers that I can actually cross multiply. And then what do we do with this one, this leftover number that we haven't used yet? We divide, okay? That's right. 3,500 divided by the number I have left. So 3,500 divided by 50. 50 does not go into 3, it does not go into 35, but it does go into 350. And I know that 5 goes into 35 7 times. 7 times 0 is 0. 7 times 5 is 35. Okay, bring down one more 0. Fill it up right there. And that shows me my percent. 35 of my 50 friends wear glasses. Those are quantities. That means that out of everybody I know on Facebook, 70% of them wear glasses in their profile pictures. See how that works? Proportions are pretty magical. They can help us figure out all kinds of things, okay? So, now that we've had a chance to play around with that, I want to talk a little bit more about percents. There's an idea with people that 100% means everything. And mathematically it does. It means this represents one whole, okay? If I have 100% of my pie left over, I haven't eaten any, right? I get to eat the whole pie because I still have 100% left. If I had 70% of my pie, that means somebody snuck in and already ate 30%. What if I told you, though, that out of 100%, I still have 300%? Does that make any sense? Can it make any sense? Well, it's kind of weird to look at, but when you see something like this, 300%, how many times bigger is that than one whole? To get from here to here, we'd have to multiply by 3, right? So that means if we have 300% of a pie left, how many pies do we really have? Well, I have 100% and another 100% and another 100%. That actually means I have 3 full pies, okay? This number can be bigger than this number. It happens all the time. So let me give you an example with something that you may have seen before. I'm going to leave this here, okay? And we're going to calculate your test score. Let's say you took a math test somewhere in school or on a computer or something like that. And there were a total of 25 problems on this math test. And not only did you ace this math test, but you actually got both extra credit questions right also. Well, what does that mean for your score, your percentage score? Let's find out. You got all 25 right, and you got the 2 extra credit ones right. So you actually got a 27 out of 25. Now, I've had this question asked to me by students and parents alike. How is it possible to get higher than 100%? 100% is the whole test. Well, not quite. 100% is the whole test that mattered, that actually counted. But you went above and beyond. You got extra points. You got 2 extra points, okay? So what does that do to your score here? Can you get a higher than 100? Happens all the time. You got all these right, which means you already got that 100. You scored, okay? To get from here to here, we have to multiply by 4. Is that right? So that means we also have to do the same thing up here. 27 times 4. 7 times 4 is 28. Carry that 2 up there. 4 times 2 is 8. Give us another 2. That gives us 10. And this is your actual percentage score on this test. You got 108%. Basically, that means you did better than perfect. You scored above and beyond the whole possible score. The reason I point this out to you is because I want you to kind of get rid of the idea that 100 is the highest number you can get in a percentage, okay? There are many physical examples that actually happen where you can score higher or get a number higher than 100%. That's kind of a misconception that I would like us to put to rest now, okay? So you will see me every once in a while bring up an example where you'll see this kind of scenario. where I will break the ceiling of what was once considered everything and add a little more to it. And it's totally legal. Mathematically, it is totally legal and it makes perfect sense. Okay? And if you've ever gotten one of these, you've been really proud of yourself. Check out the exercises underneath this video. Give them a shot, try them out. Meet me back here on the video underneath it so that we can go over the answers together. Good job.